topic for this video is about set theory. When we say set theory, it talks about a true study of infinity, which in set theory can alone measures the subject of a place prominent in human culture. But even more, set theory is the milieu in which mathematics takes place today. As such, it is expected to provide a firm foundation for the rest of mathematics. So let's define first the word set. A set is said to be a collection of a distinct object, which means when we said a distinct object, what we mean there is that the object must not have any repetition. For an example, I have here an A has an element of X, Y, and Z, which means a set A has an element of X, Y, and Z. And one more thing, a Z should be in a bold face letter. Okay, so next one that we have here is that, is it possible if we do not have any element inside the set? The answer is yes. That is what we call an empty set. An empty set or a null set is the set having no any element. So how should we write it? It's just simply as that we're going to put an open and closed parenthesis, or simply as that, like this. So when we read it, we will read it as A has no any elements. After an empty elements, what we're going to talk about is about the cardinality. When we say cardinality or cardinal number of a set, it is a number of elements inside a set. For you to understand it better, I'm going to give an example. We have here a set A, which has an element of 1, 2, 3, 4, 7, 6, and 5. We're going to count the number of a element inside set A. So what we have here is a 1, 2, 3, 4, 5, 6, 7. Therefore, the cardinality of set A is equal to 7. As simply as that. Next one that we have here is that we are going to talk about how do you define or identify a set. We actually have it 3 ways. For you to understand it better, I'm going to give an example, a January, June, and July. So we have the three, the written description, the list method, and the set builder notation. Let's start first with the written description. How are we going to describe a January, June, and July using a written description? A is the set of calendar months beginning with the letter J. So that's correct. While in the list method, we're going to describe it like a set A has an element of June, July, and January. It does not matter if it will become January, June, or July, it's just the same. So the third one is the set builder notation, which we can define as set A is a set of element X, such as X is a calendar month beginning with the letter J. So for you to understand it better, I'm going again to give you an example. I have here a wheel of a primary color. So to describe it using a written description, we could say that B is the set primary of, or rather B is the set of primary colors. Then in list method, we could say that B has an element of red, blue, and yellow. And then in set builder notation, we could say that B is an element of X, such as X is a primary color. So that's it, as simple as that. Alright, so next thing that we have here are the three basic concepts in set theory. We have first the abstraction, then the extension, and then the inclusion. So let's start first with the abstraction. How do we define the abstraction? Abstraction is simply defined as each property defines a set and each set defines a property. I have here an example. For an example, a set A has a set element of X such as P of X. Or we could also say that X in set A has a predicate of P of X. We could also say to define this one is that an x of x element of A is equal to the P of x. Next, we have the extension. Extension is defined as both sets have the same elements if and only if they contain the same element. For example, I have here set A is equal or has an element of A and B, and set B has an element of B and A. As you will notice there, they have the same element. They just have vary in the way who becomes first. Like in set A, the A becomes first after the B, and in set B, the B comes first after the letter A. But still, we could state that A is equal to B regardless of the elements, regardless of the positioning of the elements, is still the same because A is an element of A and B has an element of B and A, and then therefore A is equal to B. And the next one that we have here is the inclusion. So how do we define an inclusion? So I have again here an example. Set A has an element of 1, 2, 3, 4, 5, 6, 7, and set B has an element of 1, 2, and 3. A set A is a subset of set B. Or equivalently, B is a superset of A. Okay, so we're just going here. Okay, so it said here that set A is a subset of B because they have the same element as 1, 2, 3 is also present in set B, which is 1, 2, and 3. Or equivalently, B is a superset of A. If B contained inside A, that is, all elements of B are also elements of A, which is correct. A and B may coincide. The relationship of one set being a subset of one another is called the inclusion or sometimes contentment. So I'm going to show you Alright, so this is the set A, which is 1, 2, 3, 4, 5, 6, 7, and set B is inside the set A. So that is simply the inclusion. We can say that A is a proper subset of B, and conversely, B is a proper superset of A. So that's the end of the first part of the set theory. Thank you for listening. This is Romelyn Velasco.